Hi, my name is Yusuf, and my partner's name is Fahad, and our project is called FaceFinder. Essentially, what we do is we look at the National Missing and Unidentified Person System, or NamUS, and we scrape images from here, and we want to match them to people, be able to match them, the faces and those images, to other images, and we also want to be able to estimate what the age of the person in the image is, based on just how it looks with a CNN. So essentially, this website, if you go in, you're able to filter cases. However, you can only export the information. You cannot export images unless you press on it and export it individually. Since we needed a lot of data, we were not able to do this. We ended up going to this repository to scrape the data, and we ended up modifying these three files and forking them into our own code, which you can see over here. We essentially we modified their files a little bit so that we could be able to take their code and use it to scrape the NamUS website to get images for our data. So this is just a little boring data review. Now for the actual models. So we have two different models now. We have one that estimates the age, and then we have a pipeline that's used to be able to match people in a picture to any other picture. So for the age estimation model, this is the main part of the project. We actually ended up building our own CNN, which is described as here. This is the architecture. And we trained it and tested it on the UTK face dataset, which is over here. We found it on Kaggle, but here's the actual official website here. And this is the reference. So essentially, I'm going to go one by one. So first, for the age estimation model, like I said, we did this. We trained it and tested it on this data set, and after we got results that we were actually starting to get happy with, after trial and error with our model, we then tested it on images. Rather than from here, we tested on images from NamUS that we scraped. So, like I said, we used that repository, that code, in order to scrape NamUS's data, get those images, and then we were able to apply them to our images. So what results did we get? First of all, we had just using our test set, we got these results. For age group 0 to 15, we had an error of 6.65 years. 16 to 30, 8.05, and so on. As you can see, some of these are not that bad, but there is definitely room for improvement. Here it is plotted. And then here is a really cool graph showing the correlation between actual age and the predicted age, which is really good because we're seeing as we have a directly proportional relationship, and that just means that it's working. It could be working better, but it is still working. So that is good news for us. Now, we ended up validating, like I said, on the UTK face dataset. And then after we got the results we wanted, like I mentioned, we were able to then test it out on NamUS. So here's one example from NamUS where it looks at this picture and it says he's 66.6 years old. Now, we don't have the actual age, but visually inspecting, that's a very fair assessment. Same thing here, right? 50.1 years old. That's a very fair assessment. However, it does have some misclassifications, as over here, it says he's 44.1, which, to be honest, I would say he's in his 20s or 30s. So there is definitely room for improvement, and there are actual outliers that are much worse than this, but we do see that our model is working. So this is the CNN model that we built. Now let's go to the face matching pipeline that we did, right? So we did a face recognition pipeline, and we were able to match images from one image to another image based on comparing them, right? So how did we do this? We used the ArcFace model, basically, which is we found online. And then we did the cosine similarity between the face embeddings. So we basically looked at the embeddings of the faces. After that, what did we do? We had a threshold that we had to do because we were letting in too many values that were not what we wanted. Too many images that were below the threshold, a very low similarity. So after setting a good similarity, we started getting really good results. And then we were able to do manual validation where the user would compare and say, okay, yes, these two are the same, or yes, no, these two are not the same. And that's how we evaluated this model. Now, to evaluate our pipeline, let me go down and show you the results. So this is our precision, recall, F1 score, accuracy. As you can see, there's certainly room for improvement, but we're also seeing that because of the high precision, we saw that we have 100% precision. Our matching system is working really good. It does not work for all cases, but it's able to match and find matches very well. Here again is just a visualization of those metrics I showed you. And then here are some examples, right? Here's a 0.75 a match. Over here is a 0.61 match. Here's a 0.49 match, and here's a 0.48 match. All four of these are correct. These are clearly the same people. However, we do have a mistake over here where we're seeing 0.22, which is very low similarity. So we had a threshold that was higher than that, obviously. But because that was a threshold that we had, we were able to get a very young person matched with a very old person, which is an issue of racial bias in AI and something that we'd love to work on if we had more time on this project. So thank you for watching, and let us know if you have any questions. This is our public repository, so if you'd like to ask us questions or look at the code, feel free. Thank you.